In this lesson, we're going to learn how to graph linear equations that are written in standard form. And in standard form, you're going to see these equations that look like this: ax plus by equals c, where a, b, and c are any real number, and a and b cannot both be 0. A can be 0, b can be 0, but a and b cannot be 0. But in this case, in our problems, these will be all real numbers, and I don't think any of the problems will have 0 for A, B, and C. But we're going to do this by plotting points. Now, in the previous lesson, I just want to remind you about a previous lesson. In a previous lesson, we graphed linear equations that were in this form, where we had y by itself. Now, we did this by plotting points. We did not use anything about, in this case, this is slope-intercept form. We didn't use anything about slope or intercept because that's in another lesson that's coming up. But in this previous lesson, we graphed linear equations in which y was by itself by plotting points. In this lesson, y is not going to be by itself. It'll look like this. All right, so for example, in number 1, we have 3x plus y equal 4. So we have this linear equation. Now remember what we mean by linear equation. So if I go back to this equation here, what makes it linear is the fact that the exponents of both the variable x and y are both 1. You have that implied 1 there. Okay? And when we graph a linear equation, if you recall in the previous lesson, in the word linear, you see that word line right here. So when we graph a linear equation, we're graphing the solutions. Okay, so make sure you understood that from the previous lesson. We're graphing the solutions of this equation, and the solutions will lie on a line. And so when we graph that line, you are graphing the solutions. Okay, so let me kind of remind you about that. So if you recall in the previous lesson, we asked that question: what is the relationship between the solutions of an equation and its graph? And we saw that the solution of a linear equation will lie on its graph, and you could also think of it as the graph of an equation represents the solutions to the equation. And so you may recall that we looked at this example and we picked some ordered pairs, and we asked ourselves, or any of these ordered pairs, solutions to this equation. And when we did that, we saw that they all lay on the same line. Okay, and points outside of that line were not solutions. So that's one of the things we talked about in the previous lesson. And so in this lesson, we're going to be focused mainly on graphing equations of the form ax plus by equals c, and that's called standard form. Okay, so one of the things you can do, if possible, if you can get y by itself, then that's the easiest thing to do, because now if you can get y by itself, it now looks like what we did in the previous lesson. And then you could just plot some points using a t-table. Okay? And so we're going to do that in all the problems, but we're also going to talk about some other situations and with which students graph these or find points that are solutions to this equation. Remember, when graphing a line, though, all you need are 2 points. But we saw in the previous lesson that if you don't use 2 points, you could easily be graphing the wrong equation. All right. So you saw that where I mistakenly put an ordered pair in the wrong place, and those points were not collinear. So we knew right away that something was amiss. Okay. All right. So first thing you're going to do, if possible. All right. So try and get y by itself, and then next thing you're going to do, just like in the previous lesson, you're going to find solutions to this equation using a t-table, and then you're going to plot at least 3 points. So we just talked about the fact that in the previous lesson, if you only did 2 points, you saw that in a couple of the examples, we would have drawn the wrong graph. And then draw the line containing those points. All right, so in number 1, it is very easy to get y by itself. So let's do that. So step one would be to get y by itself. So I'm just going to write this out, get y by itself. And when I do that, let me go ahead and rewrite this over just to tell you what you have to do. So if you want to get y by itself, you're going to subtract 3x from both sides, right? And so 3x and 3x is 3x minus 3x is 0, so you get y equals, and I'm going to put the x term first, so I get minus 3x plus 4. So 4 minus 3x is the same thing as negative 3x plus 4. So I get y equals negative 3x plus 4. All right? And now I'm going to use a t-table. And all I need are 3 ordered pairs. All right. I just need 2, but you need 3 to verify that those points are collinear, because if all you use is 2 and it's the wrong graph, then you're not helping yourself there, because you could have easily found another one and then determined whether those points are collinear or not. Okay? So notice there are no fractions, so that's the easy kind, remember? That's the easy kind. No fractions at all anywhere in that. So I'm going to use 0. 0 is always a nice number to use. You can use any real number. Remember that? Any real number for x. And always choose for x first, because y is by itself. So y depends on whatever x is, because whatever x is, you're going to multiply by negative 3, and then you're going to add 4. So if x is 0, you're going to do your work here. You're going to say y equals negative 3 times 0 plus 4. So in place of x, you're going to substitute 0. Negative 3 times 0 is 0. 0 plus 4 is 4. Okay? So then 0, 4 is a solution, right? That's what we're doing here. We're finding, when we're graphing equations, whether it's linear or not, you're finding the solutions to that equation. And so right away, if you want to, you can go ahead and start plotting your points. So this is going to be number 1, 3x plus y equal 4. And so we have the point 0, 4. Remember how to plot that. You start at the origin 0, 0, the ordered pair 0, 0. Since x is 0, you're going to stay at the origin, and you're going to go up 4 since y is positive. So this is a point here. This is the point. This is the ordered pair 0, 4. Okay? All right, so let's continue on. If x is, let's say, 2, if x is 2, I get y equals negative 3 times 2 plus 4. Negative 3 times 2 is a negative 6. Negative 6 plus 4 is a negative 2. So when x is 2, my y value is negative 2. All right, very simple, right? Very simple. So I get 2, negative 2. So 2, go to the right 2, and then down 2, 2, negative 2. So there's the ordered pair, 2, negative 2. All right, now remember, don't just use 2 points. You saw in one of the previous lessons where I mistakenly put the ordered pair in the wrong place, or used a different x coordinate. So you got to be careful. So use 3 points to verify that those points. Use 3 points to verify, and use a rule if possible, that those points will all lie in the same line. So far I've found 2 solutions to this equation, but you know that there are going to be an infinite number of solutions. So you need one more to kind of make sure that they all lie in the same line. All right, so let's do one more, and I'm going to use a negative number, just to bring in a negative number. Now remember, I'm using integers. If at all possible, it's always nice to use integers. If you use decimals, you're going to have to approximate where they are on the coordinate plane. See, when you use integers, you can easily find them. They're gonna be located wherever those grid lines intersect, if they're integers. So if x is negative 1, I get y equals negative 3 times negative 1 plus 4. Negative 1 times a negative 3 is a positive 3. 3 plus 4 is 7. So when x is negative 1, my y value is 7. And so I'm going to plot that point, negative 1, 7. So negative 1, 7 is right here. So there's the point, negative 1, 7. And let's just verify that those are collinear. And, okay, so I don't think I made a mistake anywhere in plotting points or anything like that. So those are collinear. So those are three solutions, but remember you've got to find all of them, so all of them will lie on this line. And that's it. So that's number one. Okay. Now let me just kind of talk about some other thing you could have done with number one. So notice number one, what we did though was was we went ahead and we got y by itself. All right. Now some students will not do that, and that's perfectly fine. But remember, it's always nice to have integers involved here. Okay. All right, so let's look at that same problem, and I'm not going to do that with all of them, but I just want to mention something here. So we're looking at that same problem. So what some students will do, instead of just getting y by itself, they'll just do this. So for example, they'll say, all right, I'm going to let x be 0. So if x is 0, they'll go into the equation and substitute 0 in x. So they'll say, all right, I have 3 times 0 plus y is equal to 4, and then go ahead and solve y this way. So 3 times 0 is 0, 0 plus y equal 4, 0 plus y is y, that's a y there, and y equal 4, and that's what we got earlier, right? That's what we had here. Then let's look at another. Then they'll say, all right, then I'm going to let x be, let's say, negative 3 instead, negative 3. So they'll where we see the variable x, you substitute negative 3. So you get 3 times negative 3 plus y equal 4. 3 times negative 3 is a negative 9. Negative 9 plus y equal 4. And then you get y by itself. You're going to add 9 to both sides. When I combine like terms, this is 0. 9 and a negative 9 is 0. 0 plus y is y. And so you get y equals 9 plus 4, which is 13. So when x is negative 3, my y value is 13. And so now this is way, the negative 3, 13 is not in this plane, it's way outside of it. But notice that at negative 3, 13, which is up here somewhere, it will lie on that graph. Now you may say, well, do you always have to, if you don't get y by itself, do you always have to choose for x? No, you could have done this. Watch. You could have said, all right, I'm going to let y be 4. Now so just be aware that whenever you just randomly just pick numbers for x and y, when it looks like this, when it's in standard form, you could end up with a fraction. Okay, so watch. I'm going to show you something. If y is 4, I get 3x plus 4, because y is 4 this time, equal 4. Subtract 4 from both sides and combine like terms. This is 0 and this is 0 as well, right? So I get 3x equal 0. Divide both sides by 3 and then simplify. I get 3 divided by 3 is 1. 1 times x is x. And 0 divided by 3 is 0. So I get the 0.04, which I already had, right? So sometimes when you do it like this, when you pick some numbers for x and some numbers for 4, you tend to get the same ordered pairs over. All right. And I should have known that for 4 I already had it, so I should not have used it, right? I had this covered, so I really didn't see it. So let's do another one. Let's say y is 5. Y is 5. So if y is 5, I get 3x plus 5 equal 4. Subtract 5 from both sides. I get, combine like terms, I get 3x plus 0 is 3x equal negative 1. Divide both sides by 3, and then simplify. 1 times x is x, so I get x to be negative 1/3. So notice this time, I have a fraction. So when we go here, negative 1/3, 5, and you go ahead and you plot your point, you're going to have to estimate where negative 1/3 is. Okay? So you see negative 1/3 is about here, close to 0, on the left side of 0, and then 5, you're going to go up, and so there, this right here, see this right here? That is negative 1/3, 5. So whenever you don't get y by itself, you tend, if not careful, you tend to introduce fractions. And so you would have to estimate where those are. And there's nothing wrong with that. You would just have to make sure that your estimation is pretty good. Okay? All right. So whenever possible, it's always nice to get y by itself. And then you could you could then at this point, for the most part, not always, but for the most part, easily determine solutions to this equation, or points that lie on the graph that are integers for both x and y. All right, so just be aware that when you do it this way, you could introduce fractions as well. Okay. All right, and okay, so let's look at number 2. So in number 2, we have this equation, number 2. So we're going to graph negative 4x plus 2y is equal to 12. Negative 2x plus 4y equal 12. So I'm going to go ahead and show you how to get y by itself. So I'm going to add 4x to both sides, just like this. And so negative 4x plus 4x is 0. 0 plus 2y is 2y equal, and I'm going to put the variable term first. So 12 plus 4x, same thing as 4x plus 12. And then I'm going to divide both sides by 2 to get y by itself. So I'm going to go ahead and rewrite this over. I'm going to divide both sides by 2 to get y by itself. 2 divided by 2 is 1. 1 times y is y. And then what you notice, both of these are divisible by 2. So let's go ahead and use that fact. Use the fact that both of these are divisible by 2. So 4x divided by 2 plus 12 divided by 2. Okay? 4x divided by 2 is 2x. And then 12 divided by 2 is 6. So that's where I'm at. Okay. So now notice y is by itself. So it's going to make things a lot easier for me. And notice there are no fractions involved, so that's a good thing. That's a good thing that there are no fractions involved, right? So now let's use a t-table. So when I do a t-table, a nice number to use for x is 0. So since whenever you get y by itself, always substitute numbers for x first, and then you can easily find y. So if x is 0, I get y equals 2 times 0 plus 6, where we saw the variable x, you substitute 0. And then 2 times 0 is 0. 0 plus 6 is 6. So 0, 6 is a solution to this equation. All right, and you can check that just like you did in a previous lesson. So real quick, if you check that, if you want to verify that, 0, 6, you go back to the original equation, negative 4x plus 2y equal 12. And where we see the variable x, you substitute 0. Where we see the variable y, you substitute 6, right? So I get negative 4 times 0 plus 2 times 6, that's a 6. And I want to see if that's equal to 12. Well, negative 4 times 0 is 0, 2 times 6 is 12, and then 0 plus 12 is 12, which is what this side is. All right? So you can always go back, and as you find an ordered pair, you can always verify that's correct by just going back and checking to see if this side equals that side. And that's always a good idea to do. All right, so let's pick another one. So let's say x is 2. If x is 2, I get y equals 2 times 2 plus 6. So 2 times 2 is 4. 4 plus 6 is 10. So I get the ordered pair 2, 10. So the ordered pair 2, 10. That's going to be a solution, and it's going to lie on the graph. Now, as you go through the process, you want to try and find ordered pairs that are going to fit within the coordinate system you have. So notice that my largest y value I have in my coordinate system in this graph is 11. The lowest is negative 11, and then 9, and then negative 9. So this right here will fit within there, because notice the ordered pair 2, 10. Go to the right 2, and then up 10 is here. Right? So that's 2, 10. And the ordered pair 0, 6 lies here as well. So 0, 6 is on the positive y-axis, on the positive part of the y-axis. So that's 0, 6. So 2, 10 is in quadrant 1. Remember, this is quadrant 1, this is quadrant 2, quadrant 3, quadrant 4. All right, we need one more point, because I could have made a mistake anywhere in finding these points or plotting these points. So let's do one more. Let's go ahead and use a negative. So if x is, let's say, negative, let's say 4. Negative 4. I get y equals 2 times negative 4 plus 6. So I'm going to go here, where we see the variable x, substitute negative 4. 2 times negative 4 is a negative 8. Negative 8 plus 6 is a negative 2. So I'm going to plot the point negative 4, negative 2. Hopefully, it looks like it's going to lie on this line. So let's see. Negative 4, negative 2, right? And so I have this. Now, use a ruler to verify that. Use a straight edge. And so there it is. They are collinear. And so those are three solutions. But remember, you're graphing all the solutions to, and let me go ahead and rewrite this here. This is number 2, negative 4x plus 2y equal 12. So you're finding all solutions to this. So they're an infinite number of solutions. So all you do is found 3. So don't stop there, because you got to graph all the solutions. All the solutions will lie on this line. And that's it. Okay? All right, so there's the graph. So that was number 2. All right, let's look at number 3. So in number 3, so it's not difficult at all, right? Not difficult at all. It's sometimes easier, though, to do this if y is by itself. All right, so we look at number 3. All right, so number 3, let's suppose we had this. So let's suppose we wanted to graph 3x plus 4y equal 16. All right, so 3x plus 4y equals 16. So if you don't get y by itself, if you don't get y by itself, you are possibly a very good chance you are going to involve fractions in your ordered pairs. So always try to get y by itself. It makes things so much easier for you if you can get y by itself. Now you have to know, you have to mathematically make sure that when you get y by itself, that the properties you are using them correctly. The addition, property of equality, subtraction, property of equality, division, multiplication, that you're doing this all correctly. Okay. So if I'm going to get y by itself, I'm going to rewrite this over. So if you're going to get y by itself, the variable term for y by itself, you're going to subtract 3x from both sides first. And then combine like terms. 3x minus 3x is 0. 0 plus 4y is 4y equal, and let's put the variable term first. So 16 minus 3x is the same thing as negative 3x plus 16. And then we divide both sides by 4. Divide both sides by 4. 4 divided by 4 is 1. 1 times y is y. And always first, always try to rewrite this fraction, this one fraction that you see, this one rational expression, as two rational expressions, two fractions. So negative 3x, it does help. Negative 3x divided by 4, just like this. And then 16 divided by 4 is 4. Okay, it helps if you do that. Trust me, it helps. Okay, now we're going to use a t-table. Okay, now in a previous lesson, you saw how to do that. We dealt with fractions in a previous lesson when we graphed y equals some expression where we had a fraction. So remember what we said. We said, if you want all these to be integers, all the ordered pairs to be integers, you want to choose a number for x. See, that's the one that's being multiplied by negative 3/4. You want to choose a number for x that's divisible by 4. You want to use a number for x that's divisible by 4. So you're going to use multiples of 4. It's always nice to use 0. So if x is 0, I have this. I have y equals negative 3/4 times 0 plus 4. Negative 3/4 times 0 is 0. 0 plus 4 is 4. So I found a solution to this equation. I found an ordered pair, a point that will lie on its graph. Okay, so let's go ahead and start plotting those points as we go through this. So this is number 3, and it does help if you have a coordinate grid. So if you don't have a printer, find a friend or go to Office Depot and get those grids where you can draw your own. Or I'm sure Walmart would have that also, but it does help if you do this by hand and it's not scaled right. You're not going to get all your points. So just be careful. Okay, so we're going to graph 3x plus 4y equals 16. So we found a solution. one of the solutions is 0, 4, the ordered pair, 0, 4. So that's here. Okay, so that's a point 0, 4. Okay, then we're going to find two more ordered pairs, two more solutions to this equation. All right, now remember we said we have a fraction though, okay? When you have fractions, you got to think about what you're going to use for x. So give me another multiple of 4. So like 4, right? X is 4. 4 is a multiple of itself. So we have y equals negative 3/4 times 4 plus 4. All right, now remember from previous courses how to deal with multiplying fractions. So I have this fraction. I have negative 3/4 times 4, which is 4 divided by 1. The 4's divide out. You have negative 3 times 1, which is a negative 3. So this is negative 3. The 4's divide out, right? And some students like to do this. They want to say negative 3 divided by, negative 3 times 4. Let me write it over. Negative 3/4 times 4. So they want to say negative 3 times 4 is negative 12. And then remember, they'll be careful. That's a 1 right here. 4 times 1 is 4. And negative 12 divided by 4 is negative 3. You get the same thing. But it's quicker if you reduce first. All right, so this is negative 3, and negative 3 plus 4 is a positive 1. So one of my other solutions is 4, 1. All right, so we're going to plot that. So we're going to go back to the graph, and we're going to go to the right 4, and then up 1. Now do not just use 2 points, because one of these could have been incorrect. Both of those could have been incorrect, right? So find one more point. It's very easy. It only takes less than 30 seconds to find another point. So I'm going to go ahead and use a negative number this time. So another multiple of 4. So we did 4. Let's try negative 4, right? And others could have been 8, negative 8, 12, negative 12, 16, negative 16. Those are all multiples of 4. Okay. So negative 4, I get this. I get y equals negative 3/4 times a negative 4 plus 4, right? Okay. So let's kind of look at this right here. Negative 3/4, I'm going to put that here. Negative 3/4 times a negative 4 means the same thing as negative 3/4 times negative 4 divided by 1. Okay, so let's reduce. 4 divided by 4 is 1. Negative 4 divided by 4 is a negative 1. A negative 3 times a negative 1 is a positive 3. So this is 3. 3 plus 4 equals 7. All right, so I found my third ordered pair. I found my third solution. So now I'm going to go ahead and plot that point. So negative 4, 7. So I go from the origin, I go to the left 4 and then up 7. And so there's the point. Let's just verify that they are collinear, and they are collinear. All right, so let me go ahead and label it. So this is the point, negative 4, 7. All right, now remember, all you do is plot 3 points. You found 3 solutions. There are an infinite number of solutions here, so you need to graph all of them. You need to plot all of them. So that's where that line comes in. So you draw a line between them. Make sure you use an arrow. Use an arrow to indicate that it continues in both directions. All right, so that was number 3. Now, I just want to show you something. Remember, in one of the examples we said if you don't get y by itself and you're not careful, you could end up with quite a few fractions. So let me show you that. Let me just kind of show you what you would end up with. Okay, so let me go ahead and rewrite number 3. So this was number 3. So we have 3x plus 4y equals 16. So what I'm saying is that if you just go directly and use a t-table without getting y by itself, without solving for y, here's what could happen. So if you let x be 0, and most students go ahead and start with x because that's the one that's listed first column, x. So if x is 0, here's what we get. We get 3 times 0 plus 4 times y equals 16. 3 times 0, 0. 0 plus 4y equals 16. So we get 0 plus 4y is 4y. 4y equals 16. Divide by 4. You get y to be 16 divided by 4, which is 4. Okay? Which we already had right here, right? 0, 4. So far, no big deal. We got a point where both those ordered pairs, both the coordinates are integers. All right, let's do another one. If x is, let's say 5. If x is 5, let's see what happens. I get, let me do that here. I get 3 times 5 plus 4y equals 16. 3 times 5 is 15. 15 plus 4y equals 16. Subtract 15 from both sides. So you see, this is a lot of work, right? If you don't get y by itself, you're still involving quite a bit of work to get that other coordinate. So 15 minus 15 is 0. So 0 plus 4y is 4y. And then notice I have a fraction. I'm gonna get a fraction because 16 minus 15 is 1. And when I divide both sides by 4, I get y to be 1/4. So then I've got to go to my coordinate grid and then plot and estimate where the ordered pair 5 1/4 is. So 5 5 1/4 right here. All right. So see 5, and then 1/4 is close to the x-axis. All right. So you just got to be careful. It is so much easier to try to plot ordered pairs in which both coordinates are integers rather than fractions. So you'll notice that when I'm graphing linear equations, I will tend right away to get y by itself and then go from there. That way I don't have to try to worry about if I have fractions involved. All right. Okay. So just be aware. Okay. So in number 4, let's look at number 4. So in number 4 we have this. We have 2x minus 3y equal 15. So 2x minus 3y equal 15. All right. So remember, it's so much easier if you can get y by itself rather than going through all of this work every time when putting numbers into x. So I'm going to do it that way. I'm going to get y by itself. You got to be careful though, because see, this coefficient of y is negative. So just be careful. What some students will do is, since the coefficient of y is negative on the left side, they'll bring that on the right side, and that is fine. And I'll do it both ways, just in case you didn't do it that way. But what I would do is this, and as we go through the discussion, you'll see why. Since the coefficient of y is negative, because at some point you have to divide by that coefficient, right? So you can be dividing by -3. Which could make things a little bit more difficult for you if you're not careful. So I'll do it both ways. I'm going to add 3y to both sides. And so I get, when I combine like terms, this is 0. So I get 2x here equal 3y plus 15. Then I'm going to subtract 15 both sides because I want to get 3y by itself. So I get 2x minus 15 equal 3y. And to get y by itself, you divide both sides by 3, just like this. And remember we said earlier, rewrite these as two fractions. It helps if you do. So I get y equal 2/3 x, 2x divided by 3, 2x divided by 3 or 2/3 x, minus 15 divided by 3, minus 15 divided by 3, but that is 2/3 x, reduce this. 15 divided by 3 is 5, okay? All right, and so that's what you get, okay? Now, just want to show you something. If, I'm going to rewrite this over just to show you. If you decided not to bring the y term to the other side and you left it here, just be careful. So you're going to subtract 2x from both sides, just like this. 2x minus 2x is 0. 0 minus 3y is a negative 3y equal, And then I'm going to put the variable term first, so negative 2x plus 15. Then we got to divide both sides by negative 3 to get y by itself. So I'm going to rewrite this over just to show you. So you can divide both sides by negative 3, just like this. Nothing wrong. You can all do that. And so negative 3 is divided out. You get 1. 1 times y is y, equal. And then remember we said, just like we did here, you're going to rewrite this as two fractions. Okay, so you're going to say negative 2x divided by negative 3 plus 15 divided by negative 3, right? Okay, but you got to remember, you got to simplify this to make things better to deal with. You have to know, and we expect you to know, that a negative divided by negative is a positive. So you have to rewrite this. You have to. So that's going to be positive 2/3 x. See, this is this, right? And then a positive 15 divided by negative 3 is a negative 5. Okay? So it does not matter. Does not matter what you do. But if you do it this way, you just got to remember that a negative divided by negative is a positive, and then a positive divided by negative is a negative. Okay? All right, now, okay, so both of those are the same. So now we're gonna graph y equals 2/3 x minus 5. So the graph of this is the same as this because those are equivalent. These two equations are equivalent. I use properties of equality to get from here to here. So those are equivalent. The solutions to this is the same as the solutions to this. All right, so now we can use the t-table, right? Very simple, very, very simple. So xy. So I have a fraction though, so you wanna choose values of x that are divisible by 3. 0 is always divisible by this denominator, whatever denominator you have here. So let's use 0. So you notice I'll use 0 when I get y by itself. I'll always use 0 for x. So I get y equals 2/3 times 0 minus 5. 2/3 times 0 is 0. 0 minus 5 is a negative 5. So there's one of my ordered pairs. So I'm going to put that on the graph. So we're graphing, this is number 4. We're graphing 2x minus 3y equal 15. And so 0, negative 5. At the origin, you're going to go down 5. So that's this right here. So 0, negative 5. Okay. Now, let's use another. Remember, I'm trying to get all these to be integers. So let's use another number for x that is divisible by 3. So we're going to use a multiple of 3. So 3, negative 3. 6, negative 6. 9, negative 9, and so on. So let's use 3. So when x is 3, I get y equals 2/3 times 3 minus 5. 2/3 times 3 is 2. The 3's divide out, right? So that's 2 minus 5, and then 2 subtract 5 is a negative 3. So I plot the point 3, negative 3. So 3, negative 3, which is, go to the right 3, down 3. That's this right here. So 3, negative 3. All right, be careful. You could have made a mistake here, so use one more point. So if x is, let's say, negative 3, right? Negative 3. Let's see what we get. So y equals 2/3 times a negative 3 minus 5. Okay, now be careful. Go off to the side and figure this out if you have to. 2/3 times a negative 3 divided by 1, right? That's what this is. 3 divided by 3 is 1. Negative 3 divided by 3 is a negative 1. 2 times a negative 1 is a negative 2. So this is a negative 2 minus 5, which means the same thing as negative 2 plus a negative 5, which is a negative 7. So I'm going to plot the point, the ordered pair, negative 3, negative 7. So to the left 3, down 7. So there's the ordered pair, negative 3, negative 7. And notice those 3 points, which are solutions, do lie in the same line. So I've got to remember, these are only 3 of the solutions. They're infinite, so you got to indicate all those solutions using a line. And that's it. Make sure you draw your arrows on both ends. Okay? All right, let's look at number 5. Now, number 5, we have this in number 5. We have this in number 5. And listen to discussion with what I'm about to tell you in number 5. Okay, we have negative 2x plus 5y equal I'm sorry, this is number 5, sorry. Negative 5x plus 3y equal 7. Negative 5x plus 3y equals 7. Okay, so just like we did before, we're going to get y by itself. So I'm going to go ahead and rewrite this over. And so I'm going to add 5x to both sides, just like this, right? And so I get 3y equals 5x plus 7. So 3y equals 5x plus 7. Just like we did before, we're going to divide both sides by 3. So I'm going to divide both sides by 3. Divide both sides by 3, just like this. 3 divided by 3 is 1. 1 times y is y. So you have y equals 5x plus 7 divided by 3. Now, remember we got to this point. I told you, I said rewrite this as two fractions. So when you rewrite this as two fractions, you get negative 3x divided by 4 plus 16 divided by 4, right? And then reduce. So the 16/4 was reducible to an integer. We have a problem here, though. When I do that, I get 5x divided by 3 plus 7 divided by 3, right? That's what I get. And notice that is in this kind of situation where I end up with two fractions instead of one of them being an integer. So this is the one where you have to be careful. This one's going to be a little bit more difficult. This will be a little bit more challenging to get your coordinates to be integers in your ordered pairs. All right, so let's look at this. Whenever you see this, the approach I take is this. I go back and I look at this instead, that one rational expression. Okay. All right. Now, so if you want this right here to be an integer, you got to find a numerator that's divisible by 3. I'll say it again. If you want this to be an integer, you want the numerator to be divisible by 3. Okay? So for example, suppose you say, well, since my denominator is 3, I am going to set the numerator equal to 3, because 3 divided by 3 would be 1, and that's an integer. All right, but here, look at what happens when you do that, and you subtract 7 to try and get x by itself. You get 5x equal 3 minus 7 is a negative 4, and then when I divide both sides by 5, I get x to be negative 4/5. Okay, and so when you look at this, you have a fraction for x. So it makes things a little bit more difficult for you, because then you have to deal with fractions. So then you try something else. So remember we said if you want this to be an integer, you're going to need to find a multiple of the numerator that's divisible by 3, where x is turns out to be an integer also. Okay? All right, now, so let's go ahead, and instead of trying 3, let's try negative 3, see what happens. So I get 5x plus 7 equals negative 3, right? Because negative 3 is divisible by 3. But I want to solve for x where I get x to be an integer, because it makes things so much easier to graph. So I'm going to subtract 7 from both sides this time. And when I do that, look what happens. 7 subtract 7 is 0. 5x plus 0 is 5x. And I get 5x equals a negative 10. And then notice when I divide both sides by 5, I get x to be an integer, negative 2. Negative 10 divided by 5 is negative 2. So that's what I'm going to use. Now watch, once you find one, and you're not going to understand just yet what I'm about to do, but once you find one, then I can find other values of x that's going to work. That's going to give me integers here. All right, so I got x to be negative 2. Now, to find the y value, all you do is this. to find y in place of x, substitute -2. So I get 5 times -2 plus 7 divided by 3. 5 times -2 is a -10. -10 plus 7 divided by 3, which is a -10 plus 7 is a -3. -3 divided by 3 is a -1, which I knew was -1 because remember I said that equaled -3? Set this equal -3, and -3 divided by 3 is a -1. All right, but you don't have to guess at the others. You don't have to guess at the others. Once you find one where you get x to be an integer, the rest is easy. Now, you're not going to understand what I'm about to say because we haven't talked about the idea of slope. But look at the denominator. That denominator here is 3. Okay? That denominator is here. It has something to do with the slope. Okay? So what I want you to do is to add add 3 to -2. So -2 plus 3. Do that. That's 3. When I add -2 plus 3, I get 1. So if I put 1 in here, notice what happens. If I put 1 in here, notice what happens. If x is 1, and I go here and I substitute 1 for x, watch. Y equals 5 times 1 plus 7 divided by 3. 5 plus 1 is 5, and 5 plus 7 is 12, and 12 divided by 3 is 4. So I found another one. See, those are integers. Add 3 to this 1. So 1 plus 3 is 4. Let's see what happens. Okay? 1 plus 3 is 4. So if x is 4, here's what I get. I get y equals 5 times 4 plus 7, right? Divided by 3. 5 plus 4 is 20. 20 plus 7 divided by 3. 20 plus 7 is 27. 27 divided by 3 is 9. So right away, I have my 3 points, and all of them are integers. The challenging part, though, is this one's more challenging than number 3. And their only reason number 3 is so much easier than number 5 is this. This number right here turned out to be an integer. So you had one fraction and an integer. Here, you had 2 fractions. So that's where the challenging part is. All right, so you're going to see some of these problems when you do your Newton Alta assignment. It'll look like that. All right, so let's go ahead and plot those points. I know this is challenging. I understand. I know this is challenging for you. So when I plot those points, so I'm graphing. So this is number 5. I'm going to graph -5x plus 3y equals 7. And so when I do that, -2, -1. So -2, -1 is here. 1, 4 is here in the first quadrant. And then 4, 9 is also in the first quadrant. So I go to the right 4, up 9, and that's here. So 4, 9, 1, 4, and then this one was -2, -1. And when I plot those points, hopefully they're collinear, and they are. And so you just draw your line. All right. So number 5 is challenging for you only for the fact that these right here turned out to be both fractions. And the goal, if you want those to be integers, the goal is to go back to the one where we had that one fraction, that one rational expression, find a numerator that's divisible by 3 that will give you an x value that is an integer. So this one did not work. Setting the numerator equal to 3 did not work, but setting the numerator equal to -3 did work. It gave me an integer for x. Once you find that first one that gives you the integer, then you use the number that's in the denominator, and that has something to do with the aspect of slope, which you don't know anything about yet. And you just either subtract 3 or add 3 to find other points, and those numbers here will be integers. Okay? All right. So let's look at one more just to show you. Okay, we're going to do one more with this. I know it's challenging. Numbers 5 and 6 are very challenging. I will not have something like 5 and 6 on a worksheet for you to turn in, but they are part of Newton Alta. So just to let you be aware. So number 6. So in number 6 we have this one. We have negative 2x plus 5y equal negative 9. Negative 2x plus 5y equals negative 9. All right, so let's just think about this, okay? So I want to get y by itself, so I'm going to go ahead and add 2x to both sides, just like this. And when I do that, the negative 2x and 2x is 0, so you get 5y equal, and then 2x minus 9. Okay, so now I'm going to divide both sides by 5. I'm going to rewrite this over. Divide by 5, just like this. 5 divided by 5 is 1. 1 times y is y, equal to 2x minus 9 divided by 5, right? Okay, now notice that what we did before in numbers 3 and 4 was we broke this as two fractions just to see what we would get. Okay, notice that I cannot simplify this. It stays a fraction. So now that looks like number 5. So that's going to be challenging. That's our challenge problem. So I'm going to go back to this now. So I'm going to rewrite this as y equals 2x minus 9 divided by 5. Okay. So if you want to plot ordered pairs that are integers, you have got to find a numerator that's divisible by 5 that will give you an integer for x. All right, so let's try one. So let's try, see, divisible by 5. So let's use 5. 5 is divisible by 5, right? If that doesn't work, we'll use negative 5. So actually, let's use negative 5 just to show you something. So I get so negative 5 is divisible by 5, right? So I get 2x minus 9 equals negative 5. And then hopefully when I solve this equation for x as an integer, once I can find an integer, the rest is easy. So I'm going to add 9 to both sides. And when I do that, I get 2x equals negative 5 plus 9 is 4, right? So 2x, to divide both sides by 2. Divide both sides by 2, I get x to be 2, right? So hey, I found a value for x, didn't I? So right away I know this. Watch. Now it's kind of simple. So x is 2, and remember how we got 2? We set this numerator equal to negative 5. So negative 5 divided by 5 is negative 1, and this better be negative 1. And you're probably saying, why'd you get negative 1? Don't worry about it. Just what you do is this. Once you find x, you redo this over. You say y equals 2 times 2. 2 times 2 minus 9 divided by 5. And then 2 times 2 is 4. So I get 4 minus 9 divided by 5. 4 minus 9 is a negative 5. Negative 5 divided by 5 is a negative 1. Okay? So there's one of your points. Once you find one where you get x to be an integer, all you do is look at the denominator. Look at the denominator. And that has something to do with the aspect of slope. Look at that denominator and either add or subtract from this 2. So if I add 2, if I add to 2, 2 plus 5 is 7, this will be an integer. So let's do it. Y equals 2, where we see the variable x, you substitute 7. 2 times 7 minus 9 divided by 5. 2 times 7 is 14. 14 minus 9 divided by 5. 14 minus 9 is 5, and 5 divided by 5 is 1. There you go. You found one, right? Okay. Now, if you add 5 to 7, you just keep adding 5 or subtracting 5. If you add 5 to 7, that's not going to help me in terms of this grid, because 7 plus 5 is 12, right? And so when x is 12, remember, it only goes up to 9. And I don't want you to extend this because you may not scale it very well. So let's, even though I chose 12, let's go ahead and actually find the y value. So I get y equals 2 times 12 minus 9 divided by 5. 2 times 12 is 24. 24 minus 9 divided by 5. 24 minus 9 is 15, and 15 divided by 5 is 3, right? So 12, 3. And so if you did extend it, you would say, you would plot the point 12, 3. So let's go. Let's see. Did extend it. Here's 9, 10, 11, 12, and then 12, 3, 1, 2, 3 would be about here. So there's the point 12, 3. Here's the point 7, 1. 7, 1 is here, right? That's 7, 1. And then 2, negative 1 is here. And then so far you notice they do lie on the same line, right? Okay, but remember we keep adding 5. But let's do this one. Let's subtract 5 from 2. So 2 subtract 5 is a negative 3. So I'm going to use negative 3. So if x is negative 3, I'm going to get an integer here. Watch. Y equals 2 times negative 3 minus 9 divided by 5. 2 times negative 3 is a negative 6 minus 9 divided by 5. A negative 6 and a negative 9 is a negative 15 divided by 5. And negative 15 divided by 5 is a negative 3. So I get the point negative 3, negative 3. And so look, negative 3 is here, right here. And they lie on the same line. Okay? All right. So there's the graph. All right. So numbers 5 and 6 were challenging. I know they are challenging. But if you're trying to get these to be integers, all these coordinates to be integers, then you have to think about it this way. Okay? On a test or a worksheet or a quiz, they're not going to look like 5 and 6. The only reason why I brought up 5 and 6 was because you are going to see those in New Alta. But if you can do something like number 4, all right, where this fraction right here is an integer, then you're fine. All right, but 5 and 6 are a challenge. 5 and 6 are a challenge, and they are in New Alta. Okay, so now that is our discussion on how to graph linear equations that are written in this form.